Hello grade 11s, today I'm looking at page 112 of your CAM drawings. So making it slightly more challenging, they've given you your graph or sort of a diagram of your follower, and you can see that they've rotated that 30 degrees from the vertical. Always remember that wherever the follower is, that is 0 for your labeling. Your rotation is anti-clockwise, so when we label, we will label clockwise. So I'm going to start by drawing my given information over there, then we'll focus on drawing the displacement graph. So there, grade 11s, I've done some of the work. I've done my camshaft and I've hatched that with a diameter of 18. I've put in my follower with a roller bearing, diameter of 12, and the rest of that follower. Now if we label that, remember 0 is where my follower is always. They've said that our direction of rotation is anti-clockwise, so our labeling must be clockwise. So there we've done that given stuff. Now we need to do the displacement graph. This is now a very important aspect. If you mess up this point, you will mess up your drawing. We now need to take the center of the roller bearing as the lowest point of our displacement graph. Now you can take your compass and rotate that distance around, but at the same time I know that they've given us the measurement of 18 as the measurement. So what you can do is take that and just mark off your distance of 18. Okay, so there's my distance of 18, which is to the center of the roller, and project that line across, and this is going to give me the line that I'll use as the lowest point of this drawing. Now with my displacement graph, I want to work out my divisions here, and the scale they've given us is that 30 equals 8 millimeters. So 12 divisions of 8 millimeters gives me a measurement of 96. So there's my distance of 96, which I have to then break up into measurements of 8 millimeters. If I look at the information that they've given me here, it says the following. The follower rises 27, so there's a measurement of 27. Then it rises another 28, then it falls, and then goes back. So this is my overall total height. So if I work that out, my overall height is going to be 55. So I can use that as the guideline of what the height needs to be for my displacement graph. And there is the maximum height that I'm going to need for my displacement graph. I'm now going to come in and mark off my 8 millimeter divisions. There I have put in my divisions of 8 millimeters, and now do the labeling and put in my 30 degree measurements. And there I have labeled my displacement graph, put in the scale of the horizontal scale and the vertical scale. Okay, there I've completed my information, and now I'm going to do the graph. So the information in uniform motion over the first 60, it rises 27. So at 60, I'm going to mark off my distance of 27. In the next 30 degrees, the follower rises a further 28. So there's a 12 for the next 60. For the next 30, it rises 28. So I know that is my maximum height. There's a dwell period for the next 45, which means we're going to have to go half of our distance across in here. So there was my half distance, dwell period. Then it falls 15 over the next 45. So that's going to be to this point. I'll go 15. Then there's a dwell period for 45. And then over the final 75, it falls back to its original position. And there is my displacement graph. Now again, it's important to remember when I'm going to take my points across, I'm going to take them to the vertical line and then transfer them to their specific rotation. Remember as well that the point that I project across here is to the center of the roller. So once I've taken my point to its specific pizza slice, I still need to draw a circle to indicate the roller. So here is point at 30 degrees. There is from 60 to 90, 120. And this is 150 to 195. I'm now going to transfer those around to their specific points. There's my point of 30, so I'll transfer that to 30. There's 60 to 120, 60, 90, 120. And here is my points from 150 to 195. So there's 150, 180, and I'm also going to just project this, and I'll need to put a 45-degree line in to get that pizza slice. Before I forget about it, I want to just draw my circle or semicircle in here to indicate where the roller would be at each of those points. So there I'm drawing my just a little semicircle here at each point, so I can plot my shape. This is where a circle stencil might be beneficial. I'm going to take my last points across to my center line and then transfer them around. I've projected my points across now. There was my 240 to 285. There was my 300. There was my 330. Again, let's take the distance and transfer them to their respective pizza slices. This is the point for 330, so I've got that now. Here's my measurement for 300, transfer that around. Here's my point for 285. just going to put that there. 270, 240. And my last point I needed was my point of 210. Again now, remember to take your semicircle with the size of your roller and draw that in now. There I've got all my semicircles drawn. Remember, we've got to try and find a tangent that's going to flow along the shape, and it's not exactly where the circle touches the pizza slice. It can be slightly different, particularly somewhere like here, where this is going to be your edge to get that to fit around nicely here. There's no ways it can be that point. So I'm going to join that up now. So I'm going to pick a point here. Remember, try and keep this a smooth curve.
Hello? Are you boys back at school, Mark?
So we're carrying on with our curve here. I've missed that point slightly. So a very interesting design for this cam. But there you have the answer to page 112 in my workbooks, and the second example with a roller follower.